So, ladies and gentlemen, welcome. We're looking at page 288, 88, with problem 13. We're talking about trigonometric ratios. It says the slope of a line is the ratio of the change of y to the change in x, right? Rise over run, perhaps, is how you'd think about that. And it says name the trigonometric ratio of theta, all right, that equals the slope. So if this is theta, the change in y appears to be the opposite, the change in x appears to be the adjacent, and the trig ratio that compares O to A would be tangent, right? So tangent of theta would equal opposite over adjacent. Technically, you could argue, well, cotangent would equal x over y, but that wouldn't be the slope anymore. That would be the reciprocal of the slope. Am I right? I think so. So, other questions? Oh, come on, computer. Don't get the blurries.
Like number 17.
Number 17. All right, I'll crank those out real quick. And snapshot. So, moving right along. What Muppets movie was that in? Muppets Take Manhattan, maybe? No, Hollywood? I think so. But anyways. If sine of theta is 3/7, find cosecant theta. Now, cosecant theta is the reciprocal of sine, so it's just 7/3. And then here it says if cosecant theta is 2.5, find sine of theta, so it's the reciprocal, 1 over 2.5. You also could have thought cosecant theta is equal to 5/2, so sine of theta is equal to 2/5, which I like that better. I mean, yeah. And technically, let's actually consider this very situation. So suppose I've got my right triangle here. I don't know, pretend that's right. I was just trying to compile a joke, something to do with right triangles, and saying if this triangle's wrong, then maybe it doesn't want to be right. But I don't know. There's a joke hiding in there. It's somewhere. But anyways, if this is theta, let's see, cosecant cho is hypotenuse over adjacent. So 5, cho, H-O. Oh, yep. Hypotenuse over opposite, would be that. So if I wanted to find this missing side, how would I do that? Right? Pythagoras. So a squared plus 4 equals 25. A squared equals 21. Root a is equal to the square root of 21. So, so what if I asked you what is the cotangent of theta in this triangle? C-A-O. Cotangent is adjacent over opposite, so that'd be root 21 over 2. What is the cosine of theta? No? Root 21 over 5, I think I heard eventually. Cosine of theta is the ratio of the adjacent to the hypotenuse, right? So that's what that would be. What if I wanted to know what is the secant of theta? Yep, so that'd be 5 over root 21, and we'd never leave it that way. So that'd be 5 roots of 21 over 21 when I multiply top and bottom by root 21 over root 21 to rationalize the denominator. So yeah, I just want to point out you could figure out stuff like that. I could also figure out tangent if I wanted. What's tangent? Right, tangent would be 2 over root 21. So 2 roots of 21 over 21. Let's see. Oh, that's right. I'm going to teach you guys the hand trick today. It's going to be pretty good. So how about any other quick questions? It looks like a lot of people left 22 blank. Some people didn't even draw a picture of 22. Shame on you. Yeah, if you're going to leave it blank, you should at least try to represent the problem in some capacity. All right, so what two dimensions do I know on this triangle? A and B, right? The legs, right? So if I want to find the hypotenuse, I could do root 7 squared plus 9 squared equals c squared. So that's 7 plus 81 equals c squared. 88 equals c squared. So c is the square root of 88, which I believe 4 goes into that, at least 22 times. So c is going to be 2 square roots of 22. So there's my hypotenuse, 2 roots of 22. So now it says find all 6 of the trigonometric ratios. So what is sine of, oh wait, let me read these directions again. For angle R. So sine of R, cosine R, tangent R, and then their reciprocal functions, which would be cosecant R, secant R, and cotangent R, right? I'll write it down here. So, to find sine R, so from this angle's perspective, right, that is opposite over hypotenuse, so that would be root 7 over 2 roots of 22. So that would be square root of 7 times 22, 140 plus 14, 154, I think. I hope, maybe. And then root 220, 2 times 22, 44, I think, when I rationalize that all together. Do I have the answers to 22 here that I could verify? I got it right. Yay! Cosine would be adjacent over hypotenuse, so 9 over 2 roots of 22. I'd multiply by root 22 over root 22, and I'd get 9 roots of 22 over 44. Tangent is opposite over adjacent, so that's root 7 over 9. Am I right? Cosecant is the reciprocal of sine. So that would have been 2 roots of 22 over the square root of 7. So that would have been 2 square roots of 154 over 7 when I rationalize. Secant is the reciprocal of cosine, so that would be hypotenuse over adjacent, so 2 roots of 22 over 9. Am I right? And cotangent is the reciprocal of tangent, so that's 9 over the square root of 7, which when rationalized would be 9 rad 7 over 7. So that's the trick. So I couldn't have really found those until I did Pythagorean theorem. Actually, yeah, the only ones you would have been able to find at that point would have been tangent and cotangent, since those were based off of opposite and adjacent. Adjacent, I've heard some people say, which is weird. Maybe it's me. I might have said that. I just did. So those are the 6 trigonometric ratios, and as I said yesterday, that these ratios are consistently true when you take them of the same angle. All right. So sine of 47 degrees is the same as sine of 47 degrees all the time, and these ratios we'll eventually use to solve right triangles, and then even use them within solving non-right triangles. It's going to be good. Yeah, obtuse, acute triangles. Scalene triangles, that's right. Good stuff. So anyways, so there's some of our homework. It was a matter of just making sure you know those ratios, and my acronyms for them are TOA and CHO, CHA, COW. Where this one is cosecant and this one is cotangent. So, and this one is secant. So that way you don't mix up those. Right. So, yeah, bye, Internet. Forget you, Internet.